Welcome to YQ Academy Exceptions and Exception Handling Java Interview Questions and Answers. 1. What is default exception handling in Java? Default exception handling refers to the built-in mechanism provided by the Java runtime environment to handle uncaught exceptions. When an exception is thrown in a program but not caught or handled by an entry catch block, it triggers the default exception handling behavior. The default exception handling process involves the following steps. 1. Propagation. When an exception is not caught within a method, it is propagated up the call stack to the calling method. 2. Unwinding the call stack. As the exception propagates up the call stack, each method in the call stack is examined to determine if it can handle the exception. If a matching catch block is found, the exception is caught and the control flow is transferred to that catch block. 3. Termination. If the exception is not caught by any method in the call stack, it eventually reaches the top level of the program. At this point, the default exception handling behavior terminates the program and prints a stack trace to the console. The stack trace provides information about the exception. 2. Explain throw keyword in Java. In Java, the throw keyword is used to explicitly throw an exception. It allows you to create and throw custom exceptions or propagate built-in exceptions within your code. By using the throw keyword, you can raise an exception at any point in your code where an exceptional condition occurs. This can be done by providing an instance of an exception class or one of its subclasses. You can create your own custom exception classes by extending the built-in exception class or one of its subclasses. This allows you to define and throw exceptions specific to your application or domain. Here's an example that demonstrates the usage of the throw keyword to throw a custom exception. In the above example, the throw keyword is used to throw an instance of the custom exception class. The exception is caught and handled in the catch block, where the error message is printed. The throw keyword allows you to explicitly indicate exceptional conditions in your code and control how exceptions are handled. It is a powerful mechanism for error reporting and exception propagation in Java programs. 3. Can we write any code after throw statement? No, code written after the throw statement in Java will be unreachable and will result in a compilation error. The throw statement is used to explicitly throw an exception, and once the throw statement is executed, it immediately transfers control to the corresponding catch block or to the default exception handling mechanism. This means that any code written after the throw statement will not be executed. 4. Explain the importance of throws keyword in Java. 1. Signaling potential exceptions. The throws keyword provides a way to explicitly indicate the exceptions that a method may throw during its execution. By including the throws clause in the method's signature, you inform the callers of the method about the potential exceptions they need to handle or propagate. 2. Documentation and readability. The throws keyword enhances the readability and understandability of the code by documenting the exceptions that a method can throw. When developers or users review the method's signature, they can quickly identify the exceptions that need to be considered and handled appropriately. 3. Responsibility allocation. The throws keyword helps in distributing the responsibility of exception handling between methods. When a method declares that it throws a specific exception, it is indicating that it expects the caller to handle that exception or propagate it further. This helps in separating concerns and enables modular and maintainable code. 4. Exception propagation. The throws keyword enables exception propagation up the call stack. If a method encounters an exception that it cannot handle, it can declare it in the throws clause, allowing the exception to propagate to the calling method. This allows for a centralized exception handling approach, where exceptions can be handled at an appropriate level in the code hierarchy. 5. Compile time checking. The throws keyword enables the compiler to perform compile time checks for exception handling. When a method declares that it throws a checked exception, the compiler ensures that the calling code either handles the exception using a tree catch block or declares it in its own throws clause. This helps in identifying and addressing potential exceptions early in the development process. For example, in the above example, the perform operation method is declared with the throws keyword, indicating that it may throw an IR exception. Inside the method, an IR exception is explicitly thrown using the throw keyword. In the main method, when calling the perform operation method, we wrap it within a tree catch block to handle any potential IR exception. If the perform operation method throws an IR exception, it is caught in the catch block, where we print the exception message. By declaring throws IR exception in the method signature of perform operation, we are signaling to the caller of the method that they need to handle or propagate an IR exception that may occur during the execution of the method. This provides clarity and allows the calling code to handle the exception appropriately. 5. Explain the importance of finally over return statement. 1. Execution guarantee. The finally block is always executed, regardless of whether an exception is thrown or caught. This ensures that important cleanup tasks or resource releases are performed even in the presence of exceptions. On the other hand, the return statement terminates the execution of a method and may skip subsequent code if it appears before the finally block. 2. Exception propagation. If an exception is thrown inside the try or catch block, the finally block will be executed before the exception is propagated further up the call stack. This allows you to handle any necessary cleanup operations or resource releases before the exception is handled or caught by an enclosing catch block. In contrast, if a return statement is encountered, the control immediately exits the method, bypassing any subsequent code, including cleanup operations. 3. Resource management. The finally block is commonly used to release resources such as open files, database connections, network sockets, or any other system resources that need to be explicitly released. By placing the resource cleanup code in the finally block, you can ensure that the resources are properly released, even if an exception occurs during their usage. This is especially important to prevent resource leaks and to maintain the integrity and efficiency of your program. 4. Consistent state. The finally block helps in maintaining a consistent state of the program. You can use the finally block to reset variables, close connections, or perform any other necessary actions that help restore the program's state to a known and predictable state. This ensures that subsequent operations or code execution starts from a consistent state, irrespective of exceptions or early returns. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until another time, goodbye.